All right, so this example is going to let us put the triangle midsegment theorem into practice. And so we're given that P, Q, and R are midpoints of the sides DE of triangle DEF, excuse me. And so let's just kind of start there. And before we answer these questions, let's just kind of figure out what we know just from knowing that these are midpoints. Okay, so if P is the midpoint of DF, right? So P is the midpoint of DF. So that means that by the definition of midpoint, DP is congruent to PF, right? And if Q is the midpoint of FE, by definition of midpoint, QF is congruent to QE, right? And if R is the midpoint of DE, by definition of midpoint, DR is congruent to RE, right? So all those relationships are true. So now that we have a midsegment here, right? Let's start with PQ. If we have a midsegment there, PQ, then it's going to be parallel with the side that it doesn't have a midpoint on, right? The side that it's not connected to. Okay, so these will be parallel. Okay, so that's one thing we know. And we also know that PQ is half of DE, right? So it turns out DE is 12 here. So that means PQ is going to be half of 12, so it's going to be 6, right? Okay, and we also know this is going to be 6, right? Because this DE is split into two congruent segments, so that's 6, and that'll be 6 as well, right? So we can start kind of filling these things in. All right, so next, let's see about, and by the way, let's also, we'll leave it there for now. So next, let's look at RQ. So RQ is the midsegment, is another midsegment, and it must be parallel with the side that it's not connected to, which is DF, right? So RQ is congruent with DF, and it's also half of DF. So since DF is 8, that means RQ is going to be 4, right? 8 divided by 2 is 4. And so this is also going to be 4, and this is going to be 4, right? Okay. Now those are only two midsegments. There is a third midsegment that's not pictured here, or we're not, it wasn't pictured at least in the original figure, but there is a midsegment here, right? PR, which has to be parallel with FE and half of FE. So if FE is 10, then PR would be 5, and these would each be 5, right? So those are all three midsegments there if we want to include PR as well. Okay, so it says what kind of figure is DPQR? So DPQR is that figure there, right? And we can see that it's a quadrilateral, right? I mean, there's different levels to this, but it's a quadrilateral because it has 4 sides. More specifically, the opposite sides are parallel, right? It has 2 pairs of opposite parallel sides, which makes it a parallelogram. These are words that we haven't talked about too much in our class. I don't know if you've learned these in other classes. Let me get this right, parallelogram. Okay. And beyond that, we don't have all the sides the same. That would make it a rhombus, right? And the angles aren't all the same, which would make it a rectangle or a square. So, okay, so it's a parallelogram. And what is the perimeter of DPQR? So what's the perimeter if we add up all the sides? It would be 4 plus 6 plus 4 plus 6. So, or 6 times 2 plus 4 times 2. And so that comes out to 20. All right. So a few different ways you can find that.